So the reason why I'm holding off on answering the full question is because I think it's worth understanding a little bit about how everything's gotten packaged to enable multiple operating systems to coexist in the same code base. So it's worth walking those things through. It's entirely feasible to have multiple operating systems, and we want to encourage that, and ultimately get to a heterogeneous environment so that you can have different nodes on different operating systems or different versions of the same operating system, because that's clearly a requirement we see.
Right now, Crowbar by itself supports RHEL 5.6, RHEL 5.7, RHEL 6.2, CentOS 5.7, soon to be CentOS 6.2, and all the Ubuntu's from 10.10 up.
Right.
Where's the 10.04 log?
You didn't like it. It seemed like a good idea at the time to start with 10.10.
Yeah.
And then that is the primary motivator behind most of my coding decisions.
It's hard to see.
I was there before you guys, because I showed up like, hey, let's do 10.04. I'm like, how come my stuff doesn't work on your stuff anymore? It's like, oh, I'm using 10.04. You guys run 10.10.
I'm trying to get some colors I can see.
What is the color profile set to right now?
It looks fine up here, Rob.
I'm sure it does, but I can't see it on the screen. Is the problem? Let's see.
Is it representing there? Okay.
Yeah, I mean, I could pull it off the.
Crank the font size up.
What is that, term or what is that?
Yeah, it's putty. Hold the text. Let's see. Yay! Hey, that was a one checkbox fix.
All right, so Andy asked you a question.
Oh, sorry. Here's all the operating systems, by the way.
Yeah, I only heard about half of what you said, Andy. Phone issues, you know.
So,
Oh,
sounds like we lost something on Skype, but no, we're still there.
okay.
Okay. Yeesh. All right, so I'm going to step back for a second, and then Victor's going to inject places where we can broaden out a little bit. We have a lot of documentation on how to do builds. We hadn't done a lot of documentation on how to add code, and it had been incredibly confusing for people because the Crowbar repos look like there's Dell Crowbar, but if you really look at it,
There's that, and then there's 20
there's a huge number of oops, I'm not even on the right one. But there's all these. Every bar clamp has its own repo in all this stuff. So there's really good reasons to do that architecture. And the way we brought all that together is with submodules, and we're not huge fans of the submodules, but they work for what we're doing. And with Dev Tool now, I think it actually is going to become the other putty. Yes, that one. No, the white one. This putty. It's going to work out. So the way the code is structured, and I'm not going to walk through these instructions. I've already done these instructions to get set up. This is actually a cloud server, so I'm at Rackspace Cloud with this server, and I cloned out the Crowbar repo. What's the best thing to show it? I don't have any changes right now. But what happens is that in the bar clamp subdirectory, everything in this subdirectory are actually submodules using the Git submodules. So if I go back a level and do a Git submodule update,
if you do Git submodule status,
that's perfect. That's what I want. So you can see I've got a ton of all these bar clamps got brought in as submodules. One of the things that you might notice in this, I don't think I've checked out the Hadoop ones, but if I do Hadoop, it's going to bring in different bar clamps. If I do OpenStack, it'll bring in some bar clamps. So things switch around a whole bunch, and it's confusing. And then the bar clamps themselves each have their own life cycle. So there's development that goes on in a bar clamp, and then in order for Crowbar as a whole to use the new bar clamp, you actually have to update the submodule commit flag that it's using. So there was this pretty complex process where things were being going back and forth, and then we were using branches to pick which submodules to use. So I know this is confusing, but what would actually happen here is the OpenStack OS build would have a different submodule list to pull in the correct bar clamps than the master or Hadoop OS build, OS being open source. And so we found that even on our team, we would get routinely confused about it. And we knew that it was pretty confusing for a lot of other people. So we created this tool called Dev Tool, which is .dev in the Crowbar tree. And then what it's going to do is it's going to allow us...
Just silence that line.
Yeah. On this machine, it doesn't do this on my local build, but on the cloud server, I get this warning. Everything else works. It's just a... annoyance. So what's happening is that we're actually building up these release branches, and then so we can do work on these releases outside of master, and then we're using personal branches in order to allow you to do push requests. So the idea here is that for the releases that are available, Feldermouse development, which is the main trunk, Essex Hack is today's, Feldermouse is the last release, and we've done some patches against that, so it has its own branch. And I can do a dev, I can actually pick a branch. So if I want to be on I want to switch to the Essex Hack, I think I'm already on Essex Hack. Now I'm on the Essex Hack release branch set. And then I can then do a dev checkout, and you'll notice this is very similar to the Git pieces, but I want to be on the master branch for that. So of that release, I can actually be on the master hack, on the master branch.
And the thing that makes it more useful than Git is behind the scenes in the bar clamps, there's a branching structure that's similar to what's in the main bar clamp, or to what's in the main Crowbar branching structure. So like for each release, there's a release / master branch. And the dev tool keeps all the stuff in the bar clamps synchronized with what's in the main Crowbar repo, and as far as what branch you're on and what development streams you're on and all that other fun stuff.
And this is the place where it gets really powerful. So right now we don't change the Crowbar core that much. Well, Victor probably does.
I do basically all of the changes there.
But most of the dev work, right, 95% of the ongoing work is in the...
Run git blame and see whose name.
So most of the dev work is actually going on in the bar clamps. Like when I work on Crowbar UI, I'm going to go to the bar clamps, and I'm going to go in to the Crowbar bar clamp, which is where all the UI pieces are.
And you should see here now that you're on release Essex Hack Master.
So now I'm on release Essex Hack Master, which kept everything in alignment. So even though my bar clamp is on a completely separate repo, because we're using the dev tool, all those things have stayed together.
Yeah, the dev tool
really
essentially
important.
enforces the naming scheme that we're using.
So let me go back a level and go to, let's say, the Nova bar clamp. So now if we were in the Nova bar clamp, I'm not on the right. So I'm in master. Master does not have the OpenStack pieces. So what I actually need to do, I have to go all the way back.
That might work.
I need to check out the OpenStack OS build branch. Yay. So now there's the bar clamp. So what, and this is, I know it's confusing, but you have to, the submodules change depending on which branch you're on. So when I'm working on OpenStack, then the bar clamps for OpenStack are going to be populated. If I'm on master, master doesn't include any specific personality. It's just the core crowbar. So to edit Nova, I have to be on this release for today, release SX hack, and then the OpenStack OS build. That goes back for quite a while to get the OpenStack pieces included. So if I was going to make a change here,
Yeah, that needs to be wiped out.
what, the Keith? There we go. So I just made a small change, right? I want to do an add, just like normal. So I'm still using Git. That hasn't changed, and I'm going to commit. Okay.
Ooh, you need to configure some things.
This is, yeah, the problem is I don't actually mean to be, I'm not actually going to push this. I'm going to wipe it out. So let me, I'm going back to Crowbar, but I want to demonstrate what this looks like, and we'll walk through all the steps. So this is actually how I just made a change to the Nova bar clamp, and what I can now do is do a dev backup. It's going to be really wacky. So what this does is this takes the changes that I now have committed, and it's going to push them into my personal branches, my personal fork. So this is going to make what the change you just made locally exposed to everybody. Okay.
But not in the main Del Cloud Edge repos.
Right.
So it's on his forks of all the repos.
It's on the in this case the.
If you just say that, because there's a consequence of using the dev tool.
That's true. The consequence of using the dev tool is that if you look in GitHub at when I say backup, it creates, if they're not there already, it's going to create a ton of personal forks. One for every bar clamp that is in the systems.
So just you need to be aware. So is there, when you do an update, is it pulling all the bar clamps new as well then? Fetch.
Right. So the
Well, fetch will pull in changes from upstream,
Okay.
which in this case is Del Cloud Edge. And fetch only fetches, it doesn't do a pull. So you can run fetch anytime. To actually pull the changes into your working trees, there's a dev sync command that pulls in all the changes to the working trees, make sure they're synchronized across the repos that you have. And also it maintains our weird branch out structure from master to the OpenStack OS build and Hadoop OS build, and from there to a couple of Dell internal
Does
branches.
dev have usage output? Do you,
Yes, yes it does.
okay, cool.
Yeah.
Strangely enough.
He insisted that we add it. So.
Somebody has to keep saying. This was really neat.
right. So now I'm doing the pull with dev sync.
How much memory is in this VM?
I think a gig.
Okay. Yeah. And sync did nothing because you was arguing today.
Right. So at this point, I'm ready to start staging a push. If I prepare, it's okay.
Yeah, you prepare, it's fine.
So in this case, I've been going back. I've done some code. I've gotten things going. I'm all in sync. I'm ready. I've now before I do a push request, it'd be really nice to do a build. Right. Nice to always test your stuff before you make the push request.
Testing.
Yeah. Anyway, so you can do a dev build, and the cool thing about dev build, I can target an operating system. So in this case, and interestingly enough, it'll actually tell me if I say, hey, I want that. No, can't do it. These are the ones that it's tracking. So we're now at the point where we actually can show part of what we were talking about originally, which is, and Victor, you'll have to, I don't know the trees well enough to explain where all this stuff comes and goes, but basically within the trees, there's a set of directories that have the parts that are specific to those operating systems it's pulled out and separated. And we do actually a fair bit of work to make sure that this is maintained, and it's things change as we have to adapt to new operating systems. But these are the ones that are in the trees right now.
Well, and to be honest, we use it for another purpose, right? We try and keep it consistent. We internally produce a product for Dell to go and distribute and build services around. Well, if we need to update that for the field, we can't just say, oh, and Ubuntu updated these 28 packages and caused all these things to break. So we also use it as a mechanism to keep that a sanity over time kind of situation, right? So it's not just it saves us time, it's also a support kind of thing. And with that said, it bites us in other ways too.
Right.
Because we don't force everything to keep up to date. So if something breaks in the field and we haven't updated everything internally, we might not know about it until someone reports the bug saying, hey, this is working because Blue Pill, for instance, bumped their revisions 3 times and broke something that we were depending on.
So it's a mixed bag.
Yeah. But since we have to have internal deliverables for Dell and they have to be stable, we can't necessarily track everything that's happening in the wider open source community.
So from here, what we've got is, I'm just going through a build. One of the things that's really helpful with this is I didn't supply the release or the branch. I could have, and it would have actually checked out what I asked for if it was different than what I was on when it did the build. But what's cool here is it's actually going through and it's building everything on those branch and release tags for all the bar clamps. So what's really useful is it's keeping everything in sync together and letting me do a build of those pieces against my personal space.
And what you're seeing right now is the process that takes most of the time when you're doing an initial build is it has to go out and cache all of the packages that it's going to use. And it actually builds a series of chroots to make sure that it gets everything using the right environment. So, like, you could build a Crowbar based on or staged on top of RHEL 6.2 on a build VM that's running Ubuntu whatever.
Right.
And all that works.
So if somebody was going to start doing new work to support SUSE or CentOS 6.2 or Fedora, right, where we started this question, thank you. Then you would create the subdirectories, but then you could start doing builds using this system, test it, make sure it's working, get everything right, and then once it's good, you can do the push requests. We typically try to be sort of incremental, so a huge push request that touched 500,000 files would be less desirable than breaking it into small increments. But
I think you're getting into a point though about testing. So when you think about OpenStack, all the components of OpenStack, Crowbar, and the bar clamps, isn't it from a version management perspective really more a machine than a package? So the kind of approach I'm taking is generate machines, have a repository of machines,
right,
and then assemble clouds off of that. Right now, have in the background use package managers to generate machines, and then certify an entire system of machines with an integration test environment.
Yeah, we do it as a full suite.
Yeah, that's why you're doing it.
Mm-hmm.
Okay.
Yeah, we'll actually build the whole suite.
The way we test it is we actually spin up an ISO,
Yeah.
then deploy a cluster with it.
Right, and then certify.
Right.
Okay, that's
Right.
Yeah.
So and that's okay. Go ahead.
Yeah, the initial test that we do is basically a did we let the magic smoke out test, and then we have a whole team of QA folks that do more detailed testing on the back of that because the smoke test just touches the minimum necessary functionality.
And one of the things that we do for local dev, that I do for local dev work, because we're all in VMs, I will use the shared mounts on VMware. I don't know if you can do this VirtualBox, but it saves time. What happens is there's a configuration setting in the, and it's going to be hard to see on the screen for us, build Crowbar conf. So there's a whole bunch of configuration settings that you can set, obviously. And one of the things I change here is my ISO destination, and it pushes it onto the host using this shared mount. So it will literally, when I complete the ISO build, it pushes it onto my server, so I'll show you what that would look like. Yeah, so over here, I can go in, and this is where it drops it. So every time I do an ISO build, it actually drops it into the location where my VMs would pick it up to do the next full install, which makes it very fast. Saves a lot of disk space too. But, so we can really quickly turn a build, drop a new ISO, and then reinstall the whole system. We're trying with the new Barclamp import stuff to make that even shorter. So one of my options when I do this build is I can build it with no ISO, and then I can just grab the affected bar clamps and import them into a working system.
I need to look at that.
So my point here isn't necessarily to do a working build.
No, I mean that's something that's broken in the build. It didn't pull in the gem for MySQL, so that'll lead to weird knock-on effects. It should have, because it pulled in the gems for everything else at this point.
Right. So we've, obviously there's a lot of build activity that goes on, and it'll package all this, and then when it's done, it's going to put everything. I'll go back over here. So if you want just to pull the bar clamps out, those are going to be in the build cache. By default, that starts with a dot. Yeah, you can't see it at all. I can't see it. It's what build? No.
What did you last build off of? Ubuntu 12.04?
Yeah.
Go there.
So it's gonna stage it for the OS, and then it's gonna be build Dell bar clamps. Ding. So in this directory, that's really hard to see. Are all the bar clamps that got built as part of building the last build. Sweet.
Nope. Just make that echo instead of echo. Yeah.
So what this is, so if I wanted to now, I could just take out the one bar clamp that I wanted to test if I'm working on one, and then import it into my system and test just that. This is if you've done any Crowbar development, being able to work with a single bar clamp at a time is a big deal, because otherwise you end up doing a full build, which is pretty fast, but this is much, much faster.
With a populated cache, spinning up a build takes about 3 to 5 minutes.
But yeah, but then you're dealing with rebooting the whole ISO, right? Rather than just importing your bar time.
Right.
Exactly.
That's the time sink.
Yeah.
That's a big thing.
And copying the ISO around, right? Because
We've all got SSDs. It doesn't take that long.
Yeah, no. No, the problem is that, and this is where some of the OS differences are kind of interesting, and philosophies. Ubuntu says, I'm going to generate an ISO that's microscopic and has nothing on it, and expect you to go talk to the internet to get the rest of your packages.
Right.
All right, so that means what Crowbar builds is takes this little bitty ISO and then creates these huge bar clamp packages. All right.
You end up with about 1.6, 1.7 gigs of ISO at the end.
At the end.
Manageable.
Right. So then you go the other way, which is if you take like the Red Hat CentOS guys, they say, here's a 4 gig DVD that has just about everything on it you could ever want, build from it. So then you end up with these bar clamp files that are like our web app code Rails text files that get compressed down to nothing, and this ISO. So you end up with a 4 gig ISO, but you can install just about anything in the sun under it, right, on it, right? So it's a mix. And so as we talk, like if the guy who was looking at Fedora, right, looking at an OS family to start with, right, because in some regards there's 3 kind of big OS families, generalized a lot. You have your SUSE, you have your kind of Red Hat CentOS Fedora set, and then your Ubuntu set, Debian set, right? And so we do 2 of the 3 today. And so Fedora may be a reasonable thing just to like start with the CentOS image set of packages and see if that's something you could start with, right? In fact, if you look closely at the CentOS packages or the directories, they actually symlinks to the Red Hat ones.
We in Chef 0.10.6 we added platform family.
Right. Oh, yeah. So that's good too.
So Matt was saying that they had a Python family. So
Because, yeah, we had if RHEL or CentOS or
Fedora
or
yeah.
Fedora or
Fedora a lot.
Amazon.
Or SUSE.
so actually that this is we're
Enterprise
just
Enterprise.
we're just about at a really good transition point for Matt. And Matt, I wasn't going to completely throw you up on stage, but because I think we also need to talk through. And I'll stop this video and then switch to a whole new video stream. But talk through this idea of how the cookbooks and recipes respond to the operating system changes. Because while we're showing here some of the things that you need to know about operating system dependencies, a lot of it ends up being in the cookbooks. So we need to show you that. The next thing after, to wrap this topic up, it's creating the ISO. I don't care. So let me see if I can stop it. I did. Yay. And then if I want to do a dev tool, if I want to push this change after I'd spun up the ISO and tested it and made sure that it was good, then I would do a, what's the exact syntax? Pull request prep.
Doesn't matter. Pull request prep.
Oh,
Did that.
we did backup.
Okay, we did the backup.
A pull request prep. Do I need any additional?
Nope.
Okay. So pull request prep.
Oh, requests.
Requests. Yeah, because there are multiples. Pull request prep is going to evaluate all the work that I've been doing on all the submodules and all the branches and the impacts for everything. So this is the logic that we would trip on routinely before, and we've packaged it into the dev tool because it's specific to the way Crowbar has been submoduled into flexibility.
But most of what you see right here is it's actually going out and doing the fetch, the sync, and the backup, just to make sure that everything is ready to go. And when it does the pull request, that they're going to be clean.
Right. And so this is going to run through, and it's going to end with the next step, which is a pull request. It actually tells you what to type, so I never think about what it is. But it'll tell you exactly which branches and submodules that you need to check. It'll be done in a second. So this is the thing to stress. I made one change to one file, but the impact that it's going to touch is it's going to touch. In some cases, in some of the changes, a lot of changes I make, it touches multiple branches. In this case, it's touching this one branch because I'm on this one branch, and it's touching the Nova release bar clamp. So this one's pretty small comparatively. If you're working on a bar clamp that's shared across
Crowbar
multiple,
bar clamp, it's going to touch all the branches all the time.
right?
They're all related to each other.
Well, because they all have to pull in the submodule updates.
Okay.
So that it's important to use this so you can understand what's going on, and this really helps make things sort of sane. And the reason I'm shooting this video is because it's not easy the first time you do it, but hopefully you'll have the video for reference, and we can keep updating the wiki to make that happen. All right, I'm going to stop this video here.